All right, so the first step in doing our Lewis dot structures is to first find the total valence electrons of each atom that is that's engaged in the bonding. So let's take methane, CH4, for example. So carbon has 4 electrons, valence electrons, and hydrogen has 1, but there's 4 of them, so we'll multiply that by a 4. Sorry, I'm so slow doing this. All right, cool. So then we know we have a total of 4 plus 4 is 8. So total valence electrons is 8. So that's how many we have to account for when we draw our bonding. Something to remember is that 2 dots, 2 electrons equals 1 line, so 1 bond. So they're sharing that 1 electron. So if there's a double bond, there's 4 electrons. And then you have a double bond. Ooh, look, the equal sign looks just like a double bond. All right, cool. So back to the problem. So carbon, we know, likes to bond 4 times with people because it has 4 places it needs to get a new electron. So if we, and hydrogen just likes to bond once because they just need 2 to have a outside stable 8. They're an exception. They just need 2. That's because their S shell is filled. But yeah. So if you it just works out perfectly. And that's what most of them do. We'll get to some that are a little more complicated if you're going to do the AP work. The videos do a great job of explaining how that works, and that also comes down to this thing called formal charge that I'll make a video about later. But yeah, that's the basic idea, is that you just want to puzzle them all together so that they all get their valence electrons that they want. And a hint is to always put the least electronegative atom in the middle, except when it comes to carbon and hydrogen. Carbon is more electronegative than hydrogen, but it is in the middle. Hydrogen is always on the outside in those cases. But yes, cool. That's your first example. Stop it. Oh God. Let's stop this.